We discussed bubble sort, selection sort, insertion sort, and I'm writing it separately. Time complexity, remember? Anybody? Generally O(n) square. Here also O(n) square. Here also O(n) square. However, if it is sorted, then time complexity will be O(n). Any doubt? If sorted. Similarly, if it is sorted, what do you think the time complexity will be? Will it be O(n)? Agreeing or not? Anybody who is not agreeing with me? Are you sure? O(n) square what? In best case also? If everything is sorted in case of insertion sort? Yes, in selection sort O(n) square in all the cases. But in case of insertion sort, if elements are sorted, the time complexity will be O(n). Agreeing with me or not? Great. If anybody is not agreeing with me, then please let me know. Here the time complexity will be n log n, and we will going to see how it is n log n. Okay. Just remember these things, that how at least that don't say in the interviews that the time complexity is log n or O(n), because I'm taking some interviews of the last batch and they are giving the answers like this. So at least remember this thing, that time complexity will not be log n or O(n). However, if I ask you to implement everything in linked list, the time complexity will remain the same. Any doubt over this or not? If I ask you to implement bubble sort, selection sort, insertion sort in case of linked list, the time complexity will remain O(n) square. There has to be no doubt over there. And what will happen in case of merge sort and selection sort, that we will going to see. So I'm clearing it. I hope this thing will be there in your mind and you will make a note of this thing. Heap sort I will discuss with you later. Fine. Now let's discuss quick sort. So Suraj, do you think that you will be able to take it today?
Yeah, audible.
Yeah, quick sort.
Yeah, I'm audible.
Yeah, you are audible. And I am writing an input for you.
Okay.
Is it fine?
Yeah, looks fine. So we'll start with the pivot. So let's say first element is our pivot point.
Sure.
Yeah, and
Okay.
we'll have an increment pointer from I, that is from 2, and a decrement from j, last element 3.
Okay.
So yeah, we'll compare I plus plus and j minus minus with respect to 10, with respect to the pivot.
Okay.
And yeah, if the element is higher, we'll push it on the right side, and if it's smaller, we'll push it on the left side of pivot. So we'll compare 2 with pivot.
Okay.
So we have found a smaller element, so 2 is fine, and we'll start decrementing j. So the element is 3, it's not bigger than 10, so we'll continue decrementing. So j,
Where is your eye right now? Your voice
it's
got
on
cut.
2.
Is it? Okay, fine.
Yeah, and so we'll start decrementing j from the other side.
Okay.
So 3 is not greater than 10, so continue. So we'll stop at 30 for j.
Here.
Yeah, so now we'll swap I and j, that's 2 and 30.
Okay. Your I is here and J is here.
Yeah, so continue now, then I'll move to 50. So it's not smaller, so we'll continue.
Continue. I will move again.
Oh no, I messed up again. We're supposed to find the greater element on the left side. So I will stop at 50 first, not 2.
Great. So so I is here, J is here. Now tell me what will happen.
Yeah, so I will increment to 50. We need to find bigger element than the pivot.
Okay.
Yeah, and J is fine at 3. That's smaller than 10, so that's fine. So we'll swap 50 and 3.
50 and 3, right?
Yeah.
So I is here and J is still here, correct? Now what
Yeah.
will happen?
So yeah, continue. So we'll move to 30. That's not smaller. So continue. And we'll move J back. So we haven't found our elements. So as J is, as I is now greater than J, so we'll replace pivot with
No,
J.
sorry. What will happen after this? I missed it. I is
So
at 3, J is at 50.
so increment continue. So I is
What
at
will?
I will
Okay.
bet 30.
Okay.
So we found our bigger element than pivot. That's fine. Then we'll decrement J.
Okay.
So 30, it's not smaller than 10. So we'll continue. It will come to, yeah. So, but it's not smaller. So so as J is crossing over I, will swap pivot and J.
J 30 with the 10.
No, we'll continue. We'll bring J to 3 first, as we haven't found. Yeah. And now swap pivot and J. So
Like
3
this.
to 10, 30, 50. Yeah.
Okay. Now what will happen?
So now we have found a 10th position.
Okay.
Now, yeah, so 10 is fine now. Then we'll again apply quick sort to the 3 and 2 subarray and 30 and 50 subarray. So
Okay.
3.
Okay. Okay. It is fine. I'm satisfied with you.
Okay.
Okay. So let's again take it. Is it clear to everybody? If it is clear, then I'm not explaining. If it is not, then I will explain. Just be honest, because quicksort is the complex one according to me, even tougher than the heap sort. Let me explain. Okay. Okay. So in the quicksort, the idea is we will take a pivot. Pivot could be anything. Pivot could be your first element, could be your last element, could be your middle element. It depends on what algorithm you are choosing. I hope till this point everything is clear. If there is any doubt at any moment, please stop me, because quicksort is something which takes time to understand. That's why I'm taking time in this. Let me take pivot as 30. 30 means first element, right? And I will have two pointers or two loops. One I will start from here, other I will start from here. Okay. One thing what I want to do is to check whether I have reached at the end or not. I will have one element infinity or the higher element. I mean element which is larger than every other element. Just for the sake of understanding that we have reached the end. Just for the sake of that, we can remove it also, that we will see. But just for the simplicity, see that we have one element infinity at the end. Now what I'm going to do is, my idea is I want to place 30 at its correct position. Okay, that means all the elements which are smaller than 30 should be on its left side. All the elements which are greater than 30 should be on the right hand side. This is what I want to achieve right now, nothing else. I hope this thing is also clear. Now let's see how we will going to do it. So we will going to start from the right side, that means from the I, and we will going to check whether this is greater than 30 or not. If it is greater than 30, then stop. So let's see. Since 50 is greater than 30, so I will stop here. I will not move my I ahead. Now let's see J. From this side, I want to find the element which is smaller than 30. So infinity is not smaller than 30 because it is very high. So let me decrement the J. So your J will come here. Now I have found out that okay, 5 is smaller than 30. So what I will going to do, listen to this carefully, I will interchange or swap I and J. So let me do that. Apart from that, nothing will change. Apart from that, everything will remain the same. I hope this is clear. Now what I will going to do is I will going to check whether this element is smaller than 30. Yes, it is smaller. So I will move my I ahead. Why I am moving my I ahead? Because 5 is smaller than 30. But I want to find the element which is greater than 30. Since 40 is greater than 30, so I found the element. So I will not move my I ahead. Here I will decrement, I will come to J. Since 50 is greater than 30, so I will decrement my J. Why? Because I want to find the element which is smaller than J, which is smaller than pivot. So 10 is smaller than pivot. So what we can do is we can change I and J. So whenever you are finding the element which is smaller than the pivot or greater than the pivot from the left and right sides, we will going to interchange. This is I, this is J. Any doubt? This is still the pivot. Now what I will going to do is my pivot is still this P. I will going to check whether 10 is greater than 30. No. So I will move ahead. Okay. Again, I will see whether 40 is greater than 30. Yes, it is. So I will stop here. Listen to this carefully. 40 is greater than 30. So I have stopped. Following or not? Then I will try to find out any element which is smaller than J. Any element which is smaller than pivot from the J side. So since 40 is greater than 30, so I will decrement my J and J will come here. Now again see carefully. This is J, this is I. Now my I is greater than J. When my I is greater than J, then I will swap my pivot with J. Following this or not? So what will happen right now is 20, 5, 10, 30, 40, 50, infinity, because my J has been swapped with pivot. Now see a wonderful thing here. 30 has been placed at its correct position. All the elements on its left side are smaller. All the elements of its right side are greater. And this technique is called as partitioning. Now when we have performed the partitioning, then what we will do? We have two sides, one on the left hand side, other on the right hand side. So again, we will going to perform the partitioning on both sides. That is, what I mean to say is, I am having 25 and 10, one side, 30 at its middle, it has been placed at its correct position, and other side 40, 50 and infinity. Now again, we will going to perform the partitioning here. Here, pivot is 20, I is this, j is this. Here I want to find any element which is greater than 20. 5 is not greater than 20, I will move ahead. Now again what I will do is I will try to find out any element which is greater than 20. Again 10 is not greater than 20. I will move my I ahead. Now I have found out that okay, 30 is greater than 20. Clear? But j is smaller than I. So I will swap pivot with j. So this will become 10, 5, 20. Any doubt? Now my quicksort will run here. This is pivot, this is I, this is j. 5 is smaller than 10. So move your I ahead. 20 is greater than 10. But j is smaller than I. So interchange. Okay. Now coming to this side. This is pivot, this is I, this is j. Let's compare I. I is greater than j. Very good. That is what we wanted to find out, right? Okay, so let's try to find from this side any element which is smaller than 40. Decrement j. Aj is greater than 40, but we wanted to find out a smaller element. So decrement j. Now I is smaller than j. So 40 will be swapped with 40. Following this or not? So this is the thing. So if you observe, we have achieved our target of sorting the elements. Any doubt? Anybody having any doubt? Please raise it. I hope there is no doubt. So the thing is that now let's discuss about a complexity. See, if we assume that usually the pivot will be something which will divide your array into two parts. Okay, your pivot is something which is dividing your array into two equal parts. Now again your into two parts. Now again this array has been divided into two parts. This is also divided into two parts. This is also divided into two parts, and this is also divided into two parts. Ultimately, if you see, this is becoming something like n raised to power 2. This is also becoming something like n raised to power 2. This is becoming n raised to power 2, 3. This is becoming something like n raised to power 2 raised to power 4. So this can be represented like n raised to power 2k. And the length of your this array will be 1. N will be equal to 2 raised to power k. Here, if we multiply it by log base 2n, log base 2 raised to power n, this is nothing but n only. This is nothing but n only. We have did some mistake. This is k. This is nothing but k only. So k is equal to log 2. So this is the time complexity of partitioning. And we will going to do it for all elements. So it will be n to n. So this is the time complexity of your quick sort. You can take it in a two ways that we will going to perform the partitioning for each element. Ultimately, if you see, right, we are calling partitioning on each every time. Second way, you can think that there are n nodes here. So n into log 2n. Better is the first one to explain it to someone that we are performing partitioning on each element. So it is n log 2n. Please let me know if there is any doubt or not. I am assuming you are not sleeping and you are able to understand. If somebody is not able to understand quicksort, then please let me know. First question that will be asked to your in the interview will be quicksort. People know that this is the thing that generally students do some mistakes. Let's take one case. This thing here, pivot is this. This is I. This is J. Now, Siddharth, can you tell me what will happen? Let's see whether you have understood or not. Everybody. Yes, Siddharth. Hello, Siddharth, are you there? Or the lecture is boring that you are on mute if you haven't put. I think Siddharth is not here. Ayush, can you tell us what will happen now?
Sir, 1 minute. So we will compare I and pivot,
Okay.
and if I is greater than pivot, so we stopped it,
Okay.
and then we see is J is we compare J with pivot, and J is bigger, so we haven't swapped it. Then
Sorry,
we
you said that uh, AI is greater than pivot. So stop.
yes,
Second, you said what? You will compare AJ with
pivot.
greater or smaller?
AJ is greater.
Here also you said the same thing.
Yes, sir.
Okay.
And so we will increment the I. I think
Anybody who
it's
can. Ayush, some mistake is there. Anybody who can explain except Suraj. No one. So what will happen in this case is, see, we need to find from the left hand side which is greater than I, right? That is what we need to find. So 2 is greater than I. Fine. So I will not. So I. This is what we need to find. So this is fine. Now we will compare whether from right hand side we want to find an element which is smaller than pivot. So j will be decremented. Again j will be decremented. Again j will be decremented. And again j will come here. Since I is smaller than j, so pivot and aj will be swapped. So one will be swapped with itself. Any doubt? Anybody having any doubt? Please let me know. Now 2 is your pivot. This is I. This is j. Since ai is greater than pivot, so we will not move ahead. That is, I will remain here. Now let's compare with 5. We want to find an element which is smaller than 2. So we will decrement, we will decrement, we will decrement, we will come here. So we will swap pivot with aj. So this will become like this. And similarly, this thing will continue. Now, if you're observing what is happening in this case is, our tree structure is becoming like this. Because there is only one element here, there is only one element here, there is only one element here. And what is this? This is nothing but number of elements, right? I mean, the tree structure is not becoming here. This is like number of elements only. So the time complexity of this is On. That is, the time complexity of partitioning is On. And we are performing partitioning for each element. So time complexity will be n into n, which is On square. Anybody having any doubt? So time complexity when your array is sorted is On square. Now let's take this input. Yes, Ayush, now can you help us?
So we will take 5 as pivot and 4 as I and 1 as j.
Okay.
Yes, sir. As I is smaller than 5, then
Okay.
we will increment the I.
Okay.
So I will go to 3 and it will compare with pivot. It's again smaller than I, so it will again got increment, and again it will go and it reaches to the first place.
First place.
Yes, sir.
First place means?
I one.
Okay. Okay.
Then it's the final element, and j is also j is equal to I. So then pivot will swap it with j.
Okay. In that case, one thing what you can do is you can have infinity and you can move your I till this point also. Otherwise, what you said is also fine. Okay.
Okay.
So as you said that this will be interchanged. So one will come here, 4, 3, 2, 5. Now what will happen?
So now will our pivot will increase. It will go to 4,
Okay.
and I will be at 3. Then it will again compare with pivot, and it is smaller, so it get incremented, and then 4 is mm, okay. When it reaches to 5, the pivot is smaller than pivot is smaller than I. Then we will go to j, and we will compare 5 with 4.
Pivot is greater than pivot is smaller than this thing, right?
Smaller than I.
Yeah. So you have
Yeah,
found your I.
yes, sir. then we will go to J and we'll compare with pivot. And if and J is bigger than 4, so it will get incremented.
J will be incremented or decremented one?
Decremented. A
Okay.
degree. And we will compare 2 with 4. It is smaller, so
So this will become.
yes, sir.
See, one thing you did mistake here is, see, your pivot was 5, okay?
Yes,
And
sir.
it was placed at its correct position. Now your starting will be from this point. Following this point.
From 1.
Yeah.
Okay, sir.
What do you think will be the starting point?
Sir, I thought it will get incremented. So as 1. Okay, sir, it's fine. I
We
thought
are
it will.
trying to put pivot at its correct position, right?
Okay, sir. I thought I will go to the correct position, so we'll check the next one.
Okay.
Yes, sir. Got it.
You got the thing that we want to put pivot at its correct position.
Yes, sir.
So is it clear to everyone or not? Now in this case also we are doing comparisons like this. That is, our array is being divided into n elements. Now n minus 1, now n minus 2, here n minus 3, here n minus 4, which is nothing but n only. These elements are n only. And you will do partitioning for each element, so n into n, O(n) square. So your worst case complexity in case of quicksort is O(n) square. Yes, let me know if there is any doubt in anyone's mind. Arbina, Siddharth, Rajni, Shubham. So let's try to do a bit of coding here. Help me out, okay? I am pretty bad in case of C++. How to define array like this? Let's take the elements like 30. Let's take elements like 30, 40, 50, 10, 20. And let's put comma also. I hope everybody can see my screen. I'm typing something. And let's use a large element. 1000. This is extremely large. I cannot use array because this is the reserved keyword, and I hope you know about it. So let's use A only. Now also it is giving one error. Why it is giving one error?
The square bracket should come after A, syntactically.
Like this?
Yeah.
Okay. Please correct me at each moment. When you learn several languages, then syntax is out of your control. So what we need to write? We need to write quicksort. What input should be there?
Array and size, maybe.
Like this, will it work? This is the correct. Oh, okay. Array. And anything else? Here the return type is void. Here also we need to put like that.
Yeah.
And what are other inputs? Anybody can tell me? One is the low. Low means the starting position.
Yeah.
High means the highest position. So let's try to do. First, somebody is typing something. Yeah, Ayush, it is done. So let's have one pivot. Okay, pivot will be what? Starting position. Please stop me at a position where you are not able to understand. Int low will be what? Please tell me. Will it be low or low plus one? J will be what? J will be high. Suraj, what do you think? I will be low or low plus one?
Low plus one.
Someone is typing.
Yeah, it's I would say low plus one as well.
Okay, okay. Sorry, my screen got blank. Is it visible?
Yeah.
Black. Okay. Now what should I write? One do. Let's use do while. While. What do you think? Interesting point is coming here. A, I, and pivot. So should I? So let me keep on incrementing it. So on the right hand side,
Yes.
on the right hand side, so input is 30, 40, 50, 10, 20. This is I, this is J. Or J, let's keep it here for at its position. This is temporary variable, okay? This is our array. This is our pivot. So we will going to continue our I till array I is smaller than pivot. Getting this point?
Yeah. We need to find the bigger one.
Okay. Till array I is smaller than pivot. Fine.
Yeah.
If anybody is having any doubt, please raise. And we need to decrement our J while AJ is greater than pivot. I hope there is no doubt till this point. So this is the loop to find the respective elements. And if we have when we are able to find out that okay, AI is greater than AJ, then what we will do? I mean, when we have found the AI and AJ, then what should we do?
Swap.
We will swap the elements. If I is less than J, right? Is it clear? Then only we will swap.
Yep.
Help me to write one swap function. Can anybody help me out here? We don't want to use anything here. Yes, swap function.
You need
Again,
to
explain fork line 23. Okay, 23 line. I think line got pushed, Ayush, when you said 26. Okay. So I'm explaining on this screen. So Ayush, we need to find an element on the right hand side which is greater than pivot. So what I'm trying to write is I'm writing a do while loop while that means continue till you are not able to find out element which is greater than pivot. So on from this side, we need to find an element which is greater than pivot. Agreeing or not? From this point, we need to find an element which is smaller than pivot. So we are writing in a reverse way. That is, find an element which is smaller than pivot. Find an element which is greater than pivot. Clear or not now? Yes, Ayush, is it clear?
Sir, I don't know how they do while function work. I never used it, so that's why I'm not able to understand. Like if there is written that while bracket I plus plus, so when it is small, when AI is smaller than pivot, then it will increase. What's happening? It's not clear.
Okay, okay. So do while is similar to while, but your do while will be executed at least once. That's why we are using do while. That means your code will definitely come into it. If you see in this case, just observe. A40 is smaller than pivot. It is not true, right? So your code will come out of it. Are you able to understand? That means I will be one only. If the case would have been, then your I will be here, then your I will be here, then your I will come here. Clear or not now?
So like it will first go to while loop and check if the condition satisfied, then it will go to do.
It will go to do. No, do while just means a while loop only. So your
Yeah.
code is coming from above down. Just do while loop will be executed at least once.
So like if we are implementing, so first it goes to do, and then I plus plus. Then what's happening when I plus plus is executing?
So your I will be incremented.
So first it will increment to 20.
Yes, but your 20 is not smaller than this.
Yes, sir.
So it will not move ahead. So if I do you know differences between these two?
Sir, not I'm not clear with it.
Okay, okay. In this case, your I will be incremented first, then it will be compared. In this case, your I will be incremented later after the comparison.
Okay.
So just do one thing. Run do while loop for 2 3 minutes, and you will be clear with that. I'm sure.
Okay, sir.
One. So were you asking whether your I will be incremented first or not? That's what you were asking.
Yeah, sir. Like firstly, it's written I plus plus. So, sir, if it's at 10th at 10, element of 10, then first it's get incremented, and then it is comparing. I was thinking like that.
First your pivot is here, your I is here, then it will be incremented. Yes, then it will be incremented. So your 50 will be compared with this.
So, sir, it will
Now,
not compare with 40.
yeah, because you said me that make I is equal to low plus 1. So shall we change it?
Sir, I mean that like first it will compare with 40, right? 40
Yeah,
with 30.
but you told me I should be low plus 1. So I is already here, not here.
So like low,
What
low with,
what I'm trying to say is this should be this. Now is it fine with you?
so then the position of I and pivot will be the same.
Yes. Now your I will be incremented.
Yes, sir. It will goes to 40 then.
Then 40 will be compared with 30.
Yes, sir.
It will come out of this. I
Yeah.
will be 1. Agreeing or not?
Uh,
Clear or not? I is 1. This
so
is 0.
index.
This is 0. Yeah, we are studying indexes
Yes,
only,
sir.
na? See here. Just see the code.
Yes, sir.
J is pointing to what? Infinity. That high element. It will be decremented and compared. So help me out writing a swap function. How we write? Like this? Help me out, guys. Yeah. How will it work?
Temp is equal to A.
And B is equal to? I'm very bad in programming, man. Please help me out. What should I write?
Temp is equal to A and A is equal to B. Sir, 1 minute.
Okay.
Yes, sir. Temp is equal to A. Then
Okay.
A is equal to B.
Okay. Now I think it is looking fine. And here
And
B is
B is equal to temp.
okay. So tell me, will it be copy by value works in C++, right?
Yeah,
So will it work or not if I call this?
that will work.
Okay, sure.
Looks right here.
Okay. Not sure or sure?
In pass by value, right?
Pass by value. Is it pass by value or pass by reference?
And this one is pass by value.
So in pass by value, what happens?
We're creating a copy in the memory instead of using the
Okay.
direct. Yeah.
Okay. Then that copy is changed.
The copy changed, not the original one. Yeah.
So will it work or not? What I have written here. One swap is I've written one swap. These concepts needs to be crystal clear. Anybody who wants to say anything here? So let's see whether it will work or not. Okay. Let's see. Let me keep it like this. Meanwhile, if you are able to tell the answer, then it will be good. See, if I is not smaller than J, then we need to swap what?
Pivot and J.
Pivot and J. Very good. So okay. Pivot. Like this I can write?
Yeah.
Or a pivot. A pivot, right?
Yeah.
I mean A means arrow. Okay, now it is also fine. So do I need to wrap it around a loop also? While while low is smaller than high, or what?
Yeah.
What should I write here? This is fine. Okay. I'm thinking something is wrong here. Here. And this will be I.
Yeah.
And let's do little bit better than this. Okay. So is our quick sort is looking good to everyone?
Yeah.
So this is not called as quicksort. This is called as partitioning actually. So let's name it partitioning. Now we need to write the quicksort also. So this is just doing the partitioning. Let me show you what it is doing. It is just trying to find that, okay, 30 is this one. So place 30 at its correct position. This is what it is doing. So ultimately this function, what it will going to achieve? This will going to achieve like 40, 50, 30. Oh, sorry. This will going to achieve something like 10, 20, 30, 40, 50. I mean, in this case, we are able to achieve the answer, but try to understand that this function is already only doing one thing, placing pivot at its correct position.
Yeah, there's the past one.
Okay. Now we need to write one quicksort. In this, I hope I will write the correct way of using array. So quicksort. So quicksort will call this one partitioning. A array, and let's take into low into high. What is happening here? Okay. Why it is giving error?
There's a misplaced bracket on line 23 after the error declaration.
Yes. So okay. So we need to find something here. Yeah, tell me what should I do? How should I run the quicksort?
Now we need to pass the partitioning position in the quicksort.
Okay. And okay, so we need to find the partitioning position. That means the function. I mean this function.
Yeah. So maybe that should return the index of the partitioning position.
So let's call it P.
Yeah.
So, but this is not returning anything. So let's return int.
Yeah.
And return, what should I return?
J.
And this thing will be, now what is the initial? Int P is equal to, okay.
Yeah, then again call partitioning from low to J and J plus 1 to high.
Low, we need to call the?
Partitioning from
Low to high, right?
From low to J and J plus 1 to high.
But what is J here?
I mean, sorry, P.
So, but we are retrieving the value from here.
We're retrieving the index of the partition.
Yes. Let me write it here because this is top-down language.
So low and high are just.
What can you help me out? What should I write?
Yeah, partitioning.
Again partitioning.
Yeah.
Okay.
Quicksort.
Yes.
Oh yeah, quicksort. Yeah.
And here A, then
Low to J and
low to
P.
P. Yeah.
P or P minus 1?
Yep.
P.
And now again
P minus 1, as we are not using the pivot, I guess.
okay. Will it be like this?
Yeah. The array syntax is missing.
What is missing now?
The quicksort array syntax. After A, you should put a square bracket in line 55 and 56.
Do I need to do this? Do I need to write like this?
Oh no. Okay, we have already declared it.
Okay. So tell me one thing. Do you remember recursion? I need to write some base condition also.
Yeah.
Yes, sir. If low is smaller than high.
Otherwise, this will run forever. Getting this point?
Yeah. At least 2 elements.
If you do not write this condition, because when I check the When I checked the questions of some of the students during taking the interview, they were not writing this. So make sure in case of recursion, you are always writing some base condition. So is it fine, or do we need to do any other change?
So I think in line 56, we should write p minus 1.
Why? But how will you able to find the maximum element? I mean, your maximum depth. So let me say this.
On the delimiter maybe.
Yes, yes. So how will you find the delimiter? So what I'm trying to tell is, let me take the input. Let's take it to 20. Okay. No, let's take it 30, 20, 15, 40. Let's say this is the delimiter. 68, 55. Are you getting this point? Let's say this is our pivot.
Yes, sir.
Now this will be our, I mean, pivot means I place this at the correct position. Okay. Now my pivot will be this, I will be this, J will be this. Getting this point?
Yes.
J will be this. Now I will increment my I mean, I will try to find an element which is greater than 30. So this is not greater, this is not greater, this is greater, I. Now I will going to decrement my J. Remember that do while loop. We were decrementing J. If you put your J here, then you will decrement your J first. Yes, Ayush, clear or not?
Yes, sir.
We wrote like this, right? Is it clear, or shall I explain?
So the approach that I used, I haven't used this, so I thought it will work like that.
Okay, okay. Fine. I mean, there are many ways of implementing quicksort that I will going to explain to you. But I am still not sure. You are not telling me whether it will work or not. You are C++ champion. You should tell it. So let me call it. I hope I will be able to call it right in the right way. What should I pass here? Low.
0.
Okay. And here?
So we have to give the size also.
Size. So if it is 5, then we should pass 5 or 6. So my input array was this.
5. Or just taking it as an index high.
0.
See, in case of this, I'm passing this as high. So this is calling the partitioning. This is high. And see, I'm keeping my J at high position. So if the size of the elements is 5, and I'm adding this delimiter, then I should pass 5. Agreeing with me or not?
Yep.
This is my print function which I've written before. So let's keep it like this.
So we can do the like that. We can create an integer variable of index, and we will give the size of it, and then in the print function
Sorry,
we will
again.
We can create an size integer, and we
Okay.
will give size of an array, and in the print function we will write size minus 1.
So this works or not? This works?
No.
Why you said no, man? My C++ is bad, but not that bad.
No, it will calculate the size of the bytes and not the size
Okay,
of
is it so?
Yeah.
Bytes. Okay, so if I printed, okay, let me agreeing with you. I am agreeing with you. So then can I do this?
Yeah.
Now it will work? Shall I do +1? +1 agreeing or not?
Yeah. Oh, okay.
Give answer. You should be able to give answer quickly now.
So
Plus
why
one
plus one?
because this is there. But okay, this is added later, so we will not add plus one. Fine or not? So
Fine.
try to, so for one thing, keep this thing in mind. By this approach, the approach that we are using, we are adding one element at the back. So I'm trying to run it. Let's run it. Oh, segmentation fault. What happened? Segmentation fault is something, man, which if happens, you, you will never be able to find out.
So we will take size as -1 also.
Is this happening because of size?
So I think so.
Where?
In line 62, as it's getting
Which
6.
size is it? I do -1 here.
Yes, it
Okay.
might work.
No, not working. What do you think? What is going on? How do you debug segmentation faults?
So by using cout statement.
Where should I use it? Okay, let's try. Let me try after this. Hello. So you are saying that let me see. Let me do cout here.
Maybe you should paste it into an ID. It might be a simple error somewhere.
But that will make things simpler, right? Keep your life tough as possible. If you're keeping your life tough right now, then it will be easier later on. Hopefully, if the corona crisis is over. So let's. Oh, so many hellos, yeah. Is it something like in recursion or what?
Looks like an infinite loop.
So please help me out. Where should I correct it?
It's hello 203. Okay.
It's
Hello 3, hello 2, hello 3, hello 2. Okay.
is it fine? This while condition 42. So where it is occurring? It is printing hello 3, hello 2. So it is coming, going, coming, going. This is pivot is this, high integer is this. So let me do you know pointers? Can you help me out writing a swap function using pointers? Anybody? Like this?
Yeah.
This? Like this?
No, not needed. Just
But
temp.
not with temp.
Is it fine?
Temp is dereference A.
A and B.
Sorry?
Asterisk. Yeah. Asterisk there.
Then?
Then yeah, star there and it's equal to yeah, star. Yeah.
Is it fine? This is how we write.
Yeah.
Everybody agreeing with me or not? With Suraj mainly. Let's. I mean, if it does not work, we will put the blame on Suraj.
So we have used asterisk sign, right?
Okay, you have used this ampersand or star. What we write? This is
Yes,
fine.
this sign, yes.
Now shall I run it? Little less hellos. But the output is correct or not? We have written this print. So unfortunately, it is not working. So at least one thing is clear, that swap will not work if we do copy by value. Is it fine? So every time you are writing your swap, use pass by reference. This is pass by reference, right? Let me... So what do you think? Where could be the mistake right now? How do you find it out if some mistake is occurring here? Yes. If some mistake is occurring, then how do you find it out? Again, segmentation fault somewhere.
Sir, I think we should use -1
Where?
size.
So okay, here.
Yes, sir. So like this will give us 6, but the 6 index is not there.
But
-1.
this will give us 6.
Yes, sir.
Okay.
6th index is they are not there.
Again, the segmentation fault is coming. Earlier it was not coming, so let's do little control Y. So at least now, I think I deleted something. At least segmentation faults should not come. Segmentation fault is nightmare, right? It
Yes,
makes
sir.
it makes you handicapped. Why is there is something in the C out that 40, 50, 110. So what do you think? Where could be the error? One second. Int pivot is equal to, let's take it. Right, pivot into layer. So now it is fine. So one thing I did mistake here is, so this was my code before this. So as you can see, I'm taking pivot to as index, but I was comparing AI with the pivot. Are you able to understand what is the mistake here?
Yep.
So if we do like this, then I think it should work fine. Again, the segmentation fault is coming, so let's write A low because A is slow. Now I think this is fine. Let's remove the hello also. Okay, now I think it is good. So as you can see, this is the partitioning function, which is there. And there is one swap. Swap, you need to use the pass by reference. If you are doing pass by value, then I mean in pass by value, I hope the concept is clear to you. The swapping is not happening in reality, right? That's why we were running the loop forever. Getting this point? Any doubt? Anybody having any doubt? Just uh, just make sure that you are writing the code which is production ready. So that will help you score in a little better way. So I think this is fine. This I think can be converted into pivot. Can be converted into pivot. Is it fine? Let's see. Okay. No, because pivot is this changing. Okay. Pivot is, I think we are fine with this because low is the first element. Okay. So this is the quicksort algorithm which we can write. Now the thing is that when you will search the internet, then there could be multiple algorithms for the quicksort. Some of the algorithms, what they are doing is, let's say this is the input. Then they are taking this as the pivot. So this can be done. But my suggestion to you is remember one code, okay? So that you are able to write it during the interview. I hope you are getting my point. So there could be many ways of writing it. Let's say in some of the interviews, in some of the sites, if you see, they are first finding the low plus high by 2, and they are using this as the pivot. Now I don't see any issue in this, but my only problem is that you should not get confused while writing the code, right? You should not be confused. So by this, what I'm trying to say is learn one approach only, one approach, not the multiple approach. People will be happy with you if you are able to write using one approach. So Ayush was meanwhile trying to say something that we should instead of that use I minus one of p minus one. I mean, he was trying to say that. So by in the why that approach also we can follow. So this is the one code. So I'm not doing anything. I am just giving you a link to this. And where is the chat? So this is the code. Now let me write. So what I'm trying doing is quicksort 2. Just in quick way, I'm creating another project, quicksort 2. And was our quicksort 1. So in this code, what I'm trying to do is I don't want to take any element at infinity. So this is the same code, just I did the copy paste from the same code. So the objective here is we will going to implement the quicksort, but we will not have any infinity element or the largest element here. So let's try to do that. While AI is smaller than pivot. While AJ is greater than pivot. And this we will keep because we will need this. Else break. I will going to explain it what I'm trying to do. So let's remove this do also. This is one. Always follow code indentation so that mistakes are avoided. So in this case, as you can see, I'm not using any element to check whether I've reached at the end or not. So that's why I need to write I is smaller than equal to j. I think okay, I think we are good. So in this approach, the idea is we will not use infinity. We will try to compare the values of I and j. If I is smaller than j, then that means continue our I. If I becomes greater than j, then it stops at that particular moment. So partitioning is called this. Here we will not called. So this will be decremented. Why? Because now we are comparing I and j. Are you following this thing? So let's try to run. Now the output is not correct. So this thing is there. 10 has been placed at its correct position. While this will be low plus. So 0, 10, 20, 30, 40. So somehow one element is getting missed. In partitioning. So Ayush, you told initially this approach. What do you think where we are doing the mistake here?
Sir, I minus 1 in size, size minus 1.
This thing?
Yes, sir.
Okay, great. So you were saying this since beginning. Now it's finally working.
Yes,
So,
sir.
so the thing is that what we are trying to do here is we are not trying to use any extra element, any infinity in this, right? Earlier, what we were trying to do is 40, 10, 30, 40, 30, 20, 45, and we were adding infinity. Here, we are not adding any infinity. Here, we will pass the size of this, which is 1, 4, 7. So 7 minus 1 will be passed because indexes are there. Okay, indexes are like this 0, 1, 2, 3, 4. Again, the approach is same. We will try to put pivot at its correct position. Okay, we will try to put pivot at its correct position. And then we will going to pass our low and pivot minus 1 and pivot plus 1 and high. See, this is what we are doing here. Here. So I hope this code is clear to you. Now my one question I want to ask, if during the interviews they ask you what is the worst case for quicksort, then you will say if the array is already sorted in increasing or decreasing order. Now let's say in the interview they ask you to correct your quicksort, then what will you do? So the point is that 1, 2, 3, 4, 5, 6, 6, 5, 4, 3, 2, 1. These are the worst cases for quicksort. But in the interview, if someone asks you that how will you correct it, then what will you do? Yes, anyone?
Correct it means
Means complexity should not be O n square. In case of sorted one. Why the complexity is coming O n square? Because the tree was coming like this. That is, our partitioning was not happening in a correct way. So partitioning should happen in the correct way. What should we do for that?
So we can take the pivot in a midpoint.
Exactly, very good. So what you can just explain is take the pivot at the midpoint, okay? Take 3 as the pivot and try to arrange it at its correct position. So by that way, your complexity will come down. So if someone asks you what should we do in this code, how can we make this code as correct? In this, take pivot as like this. This can be taken as the pivot. But we need to do one change here, one change. We will change the position of pivot with the first element. Are you getting this point? Is it clear or not? We need to call the swap function here. Otherwise, the code that you have written below will not work. Agreeing with me or not? So this change you need to do. What happened here now?
Bracket not closed.
So the thing is that what I'm trying to tell you is you will take 3 as the pivot and it convert it into something like this: 3, 2, 1, 4, 5, and 6. Okay. Now the advantage would be this array would be converted into something like 1, 2, 3, 4, 5, 6. So pivot has been placed at the correct midpoint and it has been divided into two parts. Getting my point or not? Now again your pivot will be the midpoint. In this case nothing will be there, but in this case the pivot will be 5. So if you can appreciate this, then if our array is like this and you are taking 6 as the midpoint and changing 6 with the 1, then this is the pivot. So what it is achieving ultimately, it is dividing your size or system into two parts. Please let me know if it is clear to you or not. So your time complexity will become log n. Please let me know if it is clear or not. Others haven't even spoken in this lecture. Siddharth, Shubham, Arbina, what has happened, man? You are not even speaking in this lecture. So this is something which we can do to achieve it. But last thing by which I want to close this lecture is, can you implement quicksort? Can you implement quicksort using linked list? What's your opinion on this? Yes. What's your opinion on this? No, I mean, is it possible or not? Uh, so that is what I was trying. I'm trying to ask whether it is whether it is even possible or not. So in this cases, if you observe carefully, we are comparing indexes at each moment of time. First, we are taking this as the pivot, then that. So we are trying to access the indexes. You are incrementing it, you are decrementing J. So tell me, how will you do in case of linked list? A linked list is like this. If we take this as the integer, if we take this as the pivot, this as the I, this as the J, then try to understand that you cannot decrement your J in case of linked list. Are you agreeing with me or not? Because there is no back pointer from J to any other nodes.
Double linked list?
But what will you do in case of single linked list?
No, not possible.
So the thing is that it is possible, but you need to write some other code for that. That means what I mean to say is, no. What I mean to say is you will keep your J also here. And then you will keep on checking the elements where you are able to find the elements and change according to that. So one thing has to be clear that this approach will not work in case of in case of linked list. Second thing is that you are finding the indexes at each moment of time. Finding indexes in case of linked list is not feasible. I hope you remember that thing. Finding nodes of linked list or elements of linked list using indexes is not feasible. You need to traverse your linked list at each moment of time. So there will be issues in traversing the linked list. So try to see how can you implement the quicksort in case of linked list. Will you be able to try it? So Ayush said that he can try. So in the next lecture, we are not starting with trees. We will continue the sorting discussion, and we will see merge sort and its code. Along with that, what will happen in case of linked list. Try to see what will happen in case of linked list. What do you think? What could happen? So it is possible in case of quicksort, but by some way around. So I think now we can stop the lecture. If there is any doubt, then please let me know. This lecture is extremely important because the questions will be asked from this a lot of time during the interviews. That's why I took a lot of time. So instead of seeing my code, what I will suggest to you is write your own code. Though I have provided you the links, but if you are not able to solve, then you can use this also. So let me know if there is any doubt. Otherwise, we can end it.
Sir, I want to know one thing.
Yeah, yeah.
Sir, in binary search we have one midpoint, and in ternary search we have two midpoints. So if the array is very long, so we can create more than two midpoints.
Okay, then
Like
if the array is if the
uh,
array is
very long. Like
okay,
if
very large. Okay, then
then like suppose it has 100 elements. So if we make a binary search, it will goes to 50, and it will check the element is smaller or greater than this. But if we have ternary, we have two midpoints, so
the time complexity will get reduced. So if we create more than 2 midpoints, so like it will is it good we can use
So
more than
I'm happy that you thought about it. Unfortunately, the ternary search is slower than the binary search. So that's why I provided that question. So I'm extremely happy that you raised this question, because I thought that when you will do, then you will think about it. But unfortunately, the ternary search is slower than the binary search, and why it is slower, that you need to find out. Try to see what are the values of these log3 and log2. You need to go a little bit in the mathematics.
and so if we create more than 2 it will get more slower.
Yeah, unfortunately, that is what. So I can understand what you are thinking. You might be thinking that I will solve three things at a time, right? This is what you are thinking, right?
Yes, sir.
But unfortunately, in mathematics, if you go into mathematics, what I mean to say is finding the log3 at each moment of time. Then you will observe that the time complexity of ternary search is slower than the binary search.
Okay, sir, got it.
So I can explain it to you, but I want you to search. I want you to see. I want you to analyze a bit for this. So meanwhile, in the next lectures, I want you to write the code of each of these sort using arrays and linked lists both. Okay. So I think we are done for today's lecture. Let me know if there is any doubt. Otherwise, we can say good night, and we will meet on Sunday. Okay then. Bye. Take care.